Sedaj pa je na vrsti plenarno predavanje. Naš plenarni predavatelj prihaja iz Španije, to je izredni profesor dr. Sergio Martín Gutiérrez iz Nacionalne univerze za izobraževanje na daljavo, deluje pa na področju elektronike in telematike. Doktoriral je iz industrijskega inženirstva, sedaj pa je prorektor za izobraževalne tehnologije in tudi soodgovoren za vodenje raziskovalne skupine I4 Labs, povezana industrija in izobraževalne tehnologije za inženirstvo. Njegova raziskovalna dejavnost se osredotoča na internet stvari, na industrijo 4.0 ter mobilne in vse prisotne sisteme, pa tudi na izobraževalne inovacije, ki se uporabljajo v inženirstvu. Danes nam bo v predstavitvi se bo osredotočil na pomen spletnih laboratorijev pri tehničnih študijah za pridobivanje praktičnih kompetenc študentov. Eva, sedaj pa predajam besedo tebi za kratek nagovor.
Hvala, Mateja. Querido, o sea, estimado señor Sergio Gutiérrez. Mateja ya ha hecho una introducción en esloveno, ¿no? Para explicar cuál es su entorno que va a presentar hoy, pero en nombre de todo el equipo yo solamente quería darle las gracias por su colaboración y participación en nuestro evento. Y pues por hablar sobre un tema muy interesante y relacionado en el ámbito universitario, ¿no? Con las TIC, y por compartir sus buenas prácticas, experiencias con nuestras colegas de la universidad en Ljubljana. Y pues ahora sí, ¿no? Podemos continuar en inglés, así que la palabra es suya.
Muchas gracias. Thank you very much, Eva, for your kind questions, for your kind words and in Spanish. So it's a surprise. And thank you very much for the organization, for inviting me and for giving me the opportunity to share our research with you. So I will share my screen. Let me see. Okay, I think now you can see my slide. I'm going to put this here. Okay, so so thank you again also for the organization and for the attendees for being here. A little bit of context for my talk is I want to explain that my university is a distance learning university, is a national university. So as I was saying, we are a national university. So we cover the whole country in Spain. Also, we have centers in 15 other countries. And so we use these centers also to have like a blended model of education. We are not just online education, but more blended model, because we have in all these centers, we have what we call study centers, where there are tutors that go once every week to answer questions or to organize some practical activities with the students and so on. But this part is optional. This is only intended for those students that want to go and to complement the online education with this face-to-face part. But as I say, is optional. We have around 200,000 students, which is quite a lot. And I am in the industrial engineering faculty. The headquarters are in Madrid, and but as I say, as you can see here, we have a lot of centers everywhere. Okay, so as I was saying that I work in the industrial engineering faculty. I am computer science, computer engineer. So I also teach to computer engineers and also telecommunications engineers. And one of my main work areas is around Industry 4.0. I don't know if you are aware of this concept. Basically, it's the fourth industrial revolution. We have had several industrial revolutions, from STEM, then electric energy, then electronics, and and now we are in the industrial revolution, where we are using communications, Internet of Things, artificial intelligence, cybersecurity, big data. All these new technologies are shaping the new industrial revolution, which is called Industry 4.0. And this Industry 4.0, there is an estimation that is providing a lot of profits to companies. It's very good for companies. And so it's important, at least at national level and also at European level, there are many like projects and programs to accelerate the digital transition of industry, traditional industry, towards a digital industry, Industry 4.0. So this is something important for Europe. But when we want to do this transition, we realize that we have some challenges in the education sector that we have to face. Because in Europe, we have 2.7 million engineering students right now, which is a lot. And so we have to train these engineering students with this new, we have to teach them how to use these new technologies. I'm sorry. But on the other side, and what is more important is that there are 33 million engineers working at companies in Europe, and we have to update their knowledge also to be able to know all these technologies that because when they studied, they don't study these technologies because they are very new. So we have to help them get updated with this new paradigm. So this is a very important challenge, because these 33 million engineers will probably prefer to go to or to follow an online education instead of a face-to-face education, because it's difficult to combine work with the study, and it's difficult to combine family with the study. So probably this adult education will happen in the online world. So this is a big challenge. Also, there are other kind of students that probably will prefer online education, for example, those with some kind of disability, or all of us, we have suffered the pandemic-derived restriction of COVID-19, where we suddenly had to move towards the online education. Well, actually, we already were there, but that was some moments that we will also need to be able to teach these technical disciplines through the internet. So, and when we want to train students at least in engineering or computer science or technical disciplines, we realize that the practical skills acquisition is so important. It's something, these disciplines are practical, and they have to touch things, and they have to work with equipment, and it's a challenge, really is a challenge to teach these practical competencies online. And for us as teachers, probably some of you suffered during the pandemic, and some of you maybe struggle how to teach these practical competencies online, no? And you realize also that sometimes it's kind of a nightmare, a kind of a pain to be able to do it. And the answer is to use online laboratories. We can help students to work online with equipment or simulations of equipment thanks to the online laboratories. And there are several types of online laboratories. The first one is virtual labs. Virtual labs basically are web-based software simulation. It's nothing real. It's not real equipment. It's just a simulation, but on the web. Okay. And then we have on the other side remote labs, which is basically some piece of equipment that is that can be programmed or managed or accessed through the internet, thanks to the internet. And sometimes there is a webcam, so the student can see the equipment and the changes that happen in the equipment. And the good thing of remote laboratories is that students have the feeling that they are using real equipment. Is closer to the real experience of being on the physical laboratory. And but the remote labs have the problem of scalability. Usually, as there is a student accessing this piece of equipment, only one can access it at a time. So this is like a bottleneck. And this is one of the disadvantages of using remote labs. Instead, if we are using virtual labs, we don't have this problem of scalability. We can have many students using the virtual lab at the same time, because it's just a web and there is not really a restriction of equipment that has to be accessed. But on the other side, virtual labs doesn't give this feeling of using the real equipment. So it's not so, the motivation is not so good in this case as in the case of remote labs. And there is a third kind of laboratory, which is in the middle, which is called deferred labs. Deferred labs are basically remote labs that have been pre-recorded in a video. We pre-record all the possible situations that can happen on this remote lab, and we provide it as a virtual lab. So in this case, we have the advantages of the student having the feeling that they are using something real, but we don't have the bottleneck of using a real equipment in real time, because all the possible situations have been registered and recorded. So we have these three kind of laboratories. The disadvantages of deferred labs, obviously, is that they are much more complex to develop as the other ones. Okay, so when we think about online laboratories, clearly we see some advantages. The first one is that there is no time and space restrictions. So we are giving more flexibility to the learning process. The student will be able to study 24/7, to practice, to use this equipment 24/7. So there are more students that can use the equipment, and also as a consequence, we reduce the cost per student of the lab. And also another thing that is interesting is that we can limit inadequate usage. It means that if the student is going to do something harmful for the lab or for him, we can limit it by software. So this is also something very, very useful. And now I would like to share with you the two ways in which we are using online labs in our teaching, in our learning process at UNED. Basically, we are using it in some subjects as a substitute of face-to-face laboratories. So a student doesn't have to come to our faculty laboratories to do the practices. They just do the online practice because that these labs are good enough or real enough to ensure that the students are learning and practicing the competences and the skills that they need to do. Or in other subjects, we use these labs as a complement to the face-to-face laboratories. This means that first, the students use the online laboratory for some hours, for some days, to practice the basics, to get familiar with the lab, and then they come to the lab and as they have been familiarized through the online lab, when they come physically to the faculty labs, they take more advantage of the time in the lab. So at the end, they don't need to come so many hours because if you remember the map that I show at the beginning of my talk, we cover the whole country, and also we have centers in other countries. So when our students have to come to the faculty labs to do the practices, it's not very convenient for them, because probably they have family or they have work and they have to ask for holidays for some days to come to our faculty labs to do the practices. So we try to reduce when they have to come, and if they really need to come because there are some equipment that they have to work with it, we try to concentrate all the work in some hours, so they don't have to spend more time than needed in the physical lab. Okay, now I would like to, now that I have done this introduction, I would like to invite you to come with me in a time travel, and we are going to check, to review the online laboratories that we created some time ago, some years ago. So basically, we are going to travel back in time 10 years, well, maybe more. And some of the laboratories that we developed, for example, this laboratory was from 2010. So 14 years ago, we created this virtual lab for digital electronics. Actually, this was a laboratory awarded by the Gold Consortium, which is like the Global Online Laboratories Consortium, is the most prestigious entity regarding online laboratories. And basically, this laboratory allowed students to learn how to use digital circuits in an interactive way. This was virtual lab because it was a website. The students weren't using real circuits. It was just a pure simulation on the web. Then this same year, in 2010, we also implemented a remote laboratory for analog circuits. In this case, you see here in this picture on the top, it's a breadboard, a virtual breadboard, where the student can put some wires, some components, electronic components, and do the circuit, any circuit. And then the student just click on perform experiment. And here in the picture below, you can see there is like a matrix of components. So this matrix is able in real time to create the circuit that the student decided to create very, very fast with some relays, and create the circuit. And then the student can measure this circuit, for example, with an oscilloscope, with a function generator, with a multimeter, and they are using very realistic virtual equipment. In this case, it's like a virtual panel of an oscilloscope, but it's the same one that we have in our lab. So the student is going to spend many hours working online with this online laboratory, but when they come to the physical lab in the faculty, they realize that it's the same oscilloscope, exactly the same, with the same interface, with the same buttons, than the one that they have been working on the online lab. So they don't feel afraid, because some of this equipment is sometimes if you are not familiar, there is a difficult learning curve. So they are already familiar with this equipment, with the function generator, with the DC power, with the multimeter. And then when they come to the faculty, instead of having to spend 3 days, they spend 1, because they have been working a lot online. Another remote lab that we created is this one for programming microprocessors. In this case, it was a Motorola. This was 2011. And also this year, we created another one for programming FPGAs, also for digital electronics design. another one for PSOC, which is also for digital electronics. Yeah, my topic is digital electronics. This is why I'm going to show you many things related to this. 1 year later, we developed a virtual lab. In this case, there wasn't a physical equipment behind. It was just pure simulation of what happened in a microprocessor when a student execute a program, how data moves inside the microprocessor. And this was just virtual. This one, the color of light was, in this case, it was a real, a remote laboratory with real equipment. And basically it was designed for primary students to learn about the colors of light, how they can mix different channels of colors with the red channel, the green, and the blue channel, and how they can get any kind of color. And it was just designed for primary students. Also, this one was for primary students in 2014. These laboratories were designed to learn and to understand how, for example, wind can generate energy. This energy can be transformed into electric energy that can be afterwards used to move, for example, an amusement park. Or here at the right is more or less the same, but with solar energy, how solar energy can be transformed into electrical energy, be stored, and then how it can be used for in a city or whatever. It was for primary students. And also 1 year later, in 2015, we created, this was in this case, it was for my students at the university. It was a remote lab that allowed to program Arduino boards. Basically, Arduino is a kind of an electronic board that very popular. So in this case, students could write the programming code here at the left, and at the right, they could see through a webcam the result. In this case, the Arduino board was connected to a 3D LED cube with a lot of with a lot of LEDs and little lights that can be illuminated with any color. So a student could do kind of animations and so on. And also 1 year later, we created another remote lab. In this case, it was a robotic arm, a pneumatic arm, that the students could program. But in this case, we never used it really with real students because there were some maintenance problems because the robotic arm had to take some some pieces, put it in other place. But if the movement was wrong, then the next student couldn't do it, and it was complex to put it 24/7 for students. So we didn't really use it with my students. Also, a couple of years later, we created this other laboratory for FPGA programming, which is also similar to the other one, but with a different kind of board. And in this case, it was an open FPGA. And you see that we have been developing many labs, some more than the ones that I presented here, but basically you get the idea that we have created a lot of labs, and if you have noticed, each one of them are different. So it was quite complex, the development of these ones, and we have learned apparently some lessons from this experience, and I want to share these lessons with you. Well, the first problem that I found developing all these labs is that the development of this lab requires specialized knowledge. You need to know web programming, electronics, communications, and probably this is the reason why very few teachers include them and develop them in their subjects, because it's complex. It's complex. And also, is not only complex, but also it takes time. If you want to create from scratch a new laboratory, it takes a long time. And that's why one of the new trends that are coming up, one of the lessons that we learned is that it will be better not to start from scratch in its laboratory, but to create a platform that encapsulates a little bit the complexity, the development complexity, so we can deploy new online labs in an easy way, or at least in an easier way. And also, we found that there were some maintenance problems, both in software and hardware especially on remote labs. So this problem could also be maybe at least partially solved if we create like a more professional platform to develop these labs, because we don't have 15 different softwares to maintain, but we just have one. So maintenance gets easier. Another problem that we found is that there are long periods of time where the labs are not being used. For example, in my subjects, I use the labs for, well, my students use the labs for 1 month or 1 month and a half, but the rest of the time, my students are not using it, so they could be used for by other institutions maybe, and also during the night, at 3 in the night, 3 a.m. in the night, my students probably are not using them. So maybe some students in Australia could work during my nights, so the lab can be used more hours. And at the same time, I could use the labs from other institutions. And at the end, if we share our labs, all of us, we get better infrastructures, and we can provide better services to our students. And finally, when we are working on physical labs in the laboratory, in the faculty, we don't know much about the student learning experience inside the lab, what is happening. And also in some of the labs, the online labs that I have presented, it also happened that we don't know too much information about the learning performance. So it's also a lesson that we learned, that we have to work a little bit more on this learning analytics side. Okay, so now that we have had a look on the past, and we have obtained some lessons, some conclusions, we can travel in time again and come to the present again, and I'm going to show you what we are doing. And as we are working on the Industry 4.0 sector, we perform an analysis of bibliometric analysis and a state of the art, and we realized that there were many papers, more than 1,000 papers related to online laboratories, which means there is a high interest in the academic community, but very few, only 18, were related to Industry 4.0 remote laboratories. This means that there is a low implementation of this kind of laboratories, possibly due to the development difficulties that we have already mentioned. And that's why we thought that a project proposing an open platform to easily develop remote laboratories for Industry 4.0 could be very useful for the sector. And this is what we did. We started working on the Infor-Labs project, where we are developing an open platform to facilitate the development of Industry 4.0 remote labs. Basically, we are deploying different kind of labs, because if you remember, there are many important technologies inside this Industry 4.0 paradigm, and we are developing some remote labs for each one of them. For example, we have one for Internet of Things, we have one for big data, we have another one for cloud computing, for artificial intelligence, systems integration, robotics, cybersecurity, perception lab, etc. So we are like developing this platform that allows to easily deploy any of these lab in just a couple hours, instead of having to work for months or years. So basically, all these labs are using the Arduino remote lab platform that we have created at UNED, where basically we have any equipment that you have, a robotic arm or any kind of equipment, you just have to connect it to an Arduino board, and the Arduino board is connected to our platform, the Arduino remote lab. We put a webcam and everything is working. The student can program this equipment remotely in an easy way. So you don't need to worry about the interaction between the website and the hardware, the equipment. You don't have to worry about the concurrency of users accessing the website, because the platform manages all the access and the concurrency. And you just have to focus on the experiment design. You just have to focus on what do you want the students to learn. If you want the students to learn how to use a robotic arm or whatever, you just have to focus on this, not focus on the development and the website and so on. And this is an example of the Arduino Sensors Lab that we created. Basically, we connected all kind of sensors that can be used in an Arduino board, and the students can write the code and click on execute, and they can see the result on the webcam. And as you can see, there is here at the right, at the bottom, there is like a timer that indicates the student the time that they have left in the session, because the students have to book a slot time of 10, 15, 20 minutes, the day that they want, and they have this time slot for them to do the practice. And when this time slot finished, then the next student can come and do the practice, because in this case only one student can practice with the lab at a time. And this is another laboratory that we created based on this platform. It's an Internet of Things remote laboratory. In this case, instead of having only one Arduino board, we have several of them, in this case 3, and we connected one of the boards to a fan, another one to a sensor, and another one to a display. So we can create different kind of practices with this scenario, because all these boards are connected in different ways. They can be connected by Bluetooth or by Wi-Fi or by different kind of industrial communication protocols. So we can create with this setup many different kind of practices. You can see here how it looks like. Basically, the student can program the sensor node or the display node or the fan node, and load the code that wants to be executed in each one of them. And then we can create, as I said, different kind of practices, from easier to more complex practices, from just a standalone application in just one node, or with interaction between 2 nodes or 3 nodes, with maybe controlling the more complex practice. For example, can be that one of the nodes measures the temperature, sends this temperature to another one. This one decides if the fan has to be turned on or off to lower the temperature or not. So we can create a lot of different kind of practices thanks to this. And also, we are using the same setup for the cybersecurity lab. In this same setup, we can do practices about ciphering, communication monitorization, supplantation, denial of service. So many kind of practices can be executed in this lab. And also the system integration lab can be also used here. In this case, we are integrating some Internet of Things platform like Node-RED, which allows to define the behavior of the devices just in a graphical way. And also the student can create their own dashboards with graphics that move in real time. So it's like the same setup that can be extended to do more and more complex practices. And also we have deployed a robotic arm based on the same platform. Basically, it was so simple. We just had to connect the robotic arm to the Arduino, and everything was working. So it was quite simple. Also, we created another one for LoRa communications. And at the end, just to summarize the contributions of this project, we are encapsulating a lot of the complexity of the development of this kind of online laboratories. Instead of dedicating months or even years to develop this lab, you can deploy it in a couple hours. Just to download our software, put it in your server. That we use Raspberry Pi, which is a very low-cost device, that's 100 euros or something like that. So it's very low cost, and you can develop it your own laboratories in a very easy way. Of course, it's multilingual in Spanish and English for now, and the software or the platform manage all the concurrency and user management thanks to a booking system. And then when the student starts the time slot assigned, there's like this kind of timer that says how long, how many time does the student still have. And also we can provide some kind of default examples to allow the student to use some example and then evolve this example to more complex practices, but at the end they have to start from something. And this is a little bit of an overview of the architecture. Basically, we have a Moodle that is acting like a middleware where we connect all the labs into this Moodle, and this Moodle can be integrated in other kind of learning platform that you have in your institution. So it's very simple. And basically we are using Raspberry Pi to contain all the labs. We are using like virtual machines with Docker. So for example, we have in one Raspberry Pi, which as I said, it costs around 100 euros, the IoT lab, the cybersecurity and the integration lab, and then we have another one with the robotic lab, the perception lab. And then we, for the artificial intelligence, the big data and the cloud labs, we have a real a server, a big server. In this case, it's not low cost at all, because we need more computing power for these tasks. So for these ones, we are using this other server. And other thing that we are doing, once that we already have the online laboratories created and working, we are developing learning objects based on these online laboratories. And for that, we are using the VIS platform that basically allows you to create kind of PowerPoint presentations, online presentations, where you can embed anything. So we are integrating our online laboratories inside this inside these online presentations. So there is one of the slides. First, we provide a contextualization, orientation, how to work with the lab, and then the lab is inside the presentation. Work with the lab, and then there are some discussion and some reflection. So we follow, when we create this learning object, we follow the inquiry-based learning methodology. So because it's very convenient, I think, for this kind of practical activities. Also, we have been working on learning analytics. In this case, for the analog circuits remote laboratory for VISIR. If you remember, the student could create their own circuits with wires, with components, and this circuit translate into a connection list that you see here at the left. At the end is a connection list, so we can analyze this connection list, trying to find some patterns and to decide, okay, you are connecting this component in a wrong way, or you are doing this and this can be harmful. So we can provide some kind of recommendation, personalized feedback about the performance of the student in the laboratory. And also another thing that we are working now, and we have been working during some years, is in the definition of an standard, the first standard around online laboratories that has been created by IEEE Education Society. And we have been working on this standard to define how these online laboratories has to be developed. Basically, just very briefly, we have to define two levels. In the first level, we have to create the lab as a service with a set of APIs, services, and metadata. And then on top of that, we have to add another level, level 2, where we are going to encapsulate these labs into learning objects. So, and we are going to apply learning analytics using XAPI. But after working on the standard, we also realized that there are some problems, and that I also want to share with you. The first one is that the development of new online laboratories following the standard is very complex. There is a high complexity when we want to follow the standard, and that's why only some of the people involved in the development of the standard is really implementing it. So there is just very few laboratories following the standard, and very few publications can be found. So one of the lessons learned also from this work is that maybe we have to somehow we have to work on the standard to make it easier to be applied. And another thing that we are working on is Lab Federation. In this case, we are sharing these online laboratories with other institutions, thanks to a platform called WebLab Deusto. And this platform allows you to share and reuse laboratories in different institutions. For example, if I have a VISIR in my institution, and other institutions also have other kind of VISIRs, we can all share all the experiments. And if my VISIR one day is down for maintenance, it doesn't matter, because my students can use the VISIR in one of the other institutions. And also another trend is the use of professional remote lab services. For example, this company, Labsland, is providing professional remote labs that you can buy and install in your institution, or you can just use it as a service, pay a small fee and use it as a service in a reliable way. So also they have like a very big catalog of laboratories that you can find, and sometimes when you develop your own laboratories, they are not so professional because you are not an expert on that. And these people knows how to do the laboratories. Okay, and so now that we have seen what happened in the present in our research, we are going to travel in time again, in this case, towards the future, to see a little bit of what we are going to do in the next months or years. The first thing is that we have to finish some of the online laboratories. We didn't finish yet the big data lab, the cloud computing lab, and the artificial intelligence lab. So this is where our focus will be in the following months. And also we are integrating artificial intelligence in the online laboratories. So it can provide some kind of personalized feedback to the students analyzing the code, but this is not intended to provide the solution to the practice, but to provide hints and to help the student understand the things that they are doing they are not doing well, or the things that can be done in a more efficient way, maybe. And also we have to work more on federation of labs, because there are many federations out there, to be true. So we have to go on reusing and sharing labs with other institutions, and we have to work more on the standard to make it more accessible, easier to apply. We have to create more labs as a service, create more labs as learning objects, and to apply more learning analytics. And well, that's all in my presentation. Thank you very much for listening, and if you have any question, I will be very happy to answer.
Thank you, Sergio, very much. Are there any questions, maybe? It's not written in chat yet.
Can I ask a question?
Sure.
You did exactly what we would need. So my question is, if I would like to speed up my implementation of labs for students using your Infor Labs, what's the way to go?
Yeah, we are publishing the code in the project website. If you want to, you can send me an email, and I can help you even more. But in the project website, which is Infor Labs, the project is Infor Labs. If you Google it, probably you will get information. But anyway, you can send me an email, and we can help you in the process.
Okay. And the next short question, it's an amazing development that you did until now, and I imagine that teachers couldn't do it all this in their spare time. So how did you finance all this?
Yes, actually, we usually use students to create the laboratories, like final master thesis or final projects. But at the end, we realized it was not very efficient because they are not professionals of remote laboratories development. And that's why we created this platform with a professional person. So now all the new developments are very easy, just to plug and play almost. And it's very easy now.
Thank you very much. Congratulations for all this.
Thank you for your interest.
Thank you. Maybe just one more question. Thank you for a really great presentation. And you have really done a great work, a lot of work. And I think that this aspect where you are sharing all your results, all these labs, is something really valuable nowadays. So I have just one short question. So you mentioned also that you are testing those labs with students. So what are some responses from their side? Do you have you checked what is the impact of those using virtual labs in comparison with traditional labs? So what is some insight from students?
Yes, in principle, students are very, very happy to to have this kind of resources, because you can imagine if you are living in Germany and you have to travel to Madrid to do the practices of digital electronics, it's not very convenient for your personal or professional life. So if you provide this way of using almost as good as the laboratories that they have in the faculty, they are so happy because they can use them during the night, after work, during the weekend. So it's more flexible for and convenient for their learning process. We are helping them to adjust their needs to the learning process. So for now, all the evaluation that has been done is very, very promising.
Great, great, thank you.
Okay. Any more question maybe? No? Okay. So thank you, Sergio, very much. Muchas gracias. And if there's no other questions, we will move on with other presentations.
Perfect. Thank you very much. See you.
Thank you.
Bye.